Have you ever stopped to truly consider what lies hidden deep inside a volcano? It's a question that sparks the imagination, leading us to ponder the immense forces at play beneath our feet. From the outside, a volcano may appear as just another mountain, a serene part of the landscape. It stands as a silent giant, peacefully sleeping against the vast canvas of the sky, but beneath its calm and unassuming exterior, an extraordinary and powerful process is constantly unfolding. A dramatic story of intense heat, immense pressure, and the Earth itself breathing fire in a spectacular display of raw power. Our planet is a living entity, constantly reshaping and reinventing itself from the inside out through dynamic geological processes. To truly understand this awe-inspiring spectacle, we must embark on a journey deep beneath the surface, venturing into the unknown, far below the tranquil and peaceful slopes that we see above. Imagine peeling back the layers of the Earth like an onion, revealing its hidden secrets, traveling down through layers of soil and solid rock, each telling a story of time and pressure into a subterranean world of ever-increasing and almost unbearable heat. Here, under the crushing weight of an entire mountain range, the pressure is unlike anything we can comprehend on the surface, lies a hidden chamber. It's not a simple cave or cavern, but a vast and expansive reservoir holding unimaginable heat and raw, untamed power. This is the magma chamber, the very heart and engine room of the volcano, connected to the surface world by an intricate network of subterranean pipes and conduits. These crucial pathways are called vents, and they serve as the primary channels through which the fiery heart of the planet will one day violently erupt. The majestic volcano we see towering above the landscape is merely the tip of this immense and complex geological structure, the final exit point, the grand finale for a planetary furnace of truly epic proportions. For now, that exit may be sealed shut, appearing dormant and inactive, but the pressure deep below is relentlessly building, accumulating year after year, unseen and unfelt by most. The sleeping giant is slowly but surely gathering its strength, preparing for what is to come, patiently waiting for the precise moment when the immense forces contained within can no longer be suppressed or contained. The story of its inevitable and dramatic awakening is destined to be one of the most spectacular and awe-inspiring events in the entire natural world. Now let's venture deep into the Earth, to the very heart of this fiery process. We're about to explore a geological feature of immense power and significance, the magma chamber. This is where the magic, or rather the science, happens. This isn't just a hollow cavern, a simple void in the Earth. It's a far more complex structure, a vast sponge-like region permeated with molten rock. It's a dynamic environment filled with partially molten rock, a substance caught between solid and liquid states. This seething, semi-liquid mass is churning under tremendous pressure, a force that shapes the very landscape around it. Magma here is a thick, glowing liquid, a river of fire contained within the Earth. It's a primordial soup of melted silicates, the fundamental building blocks of our planet, crystals slowly forming within the molten rock, and dissolved gases, all contributing to the volatile nature of this underground realm. The chamber itself can stretch for miles, a vast and interconnected network of molten rock. It's a hidden ocean of fire, a subterranean sea of immense power. This fiery ocean is in constant motion, a dynamic system of currents and flows. Hotter, less dense magma rises towards the surface, driven by buoyancy. As it cools, the material becomes denser and sinks back down, creating a cycle. This process creates a slow, perpetual convection cycle, a fundamental driver of volcanic activity. Gases like water vapor, released from the molten rock, add to the complexity, and carbon dioxide are trapped within the magma, adding to the immense pressure. All of this is contained by the immense weight of the rock layers above, a geological vice. The gases are waiting, compressed and eager, for the pressure to be released, for an opportunity to escape. The chamber grows in size as more surrounding rock melts and is incorporated into the magma, expanding its reach. Conversely, it shrinks as magma cools and solidifies, losing volume and energy. A swelling chamber, detected by subtle ground deformation, signals an active volcano, a sign of impending activity, while a cooling one hints at dormancy, a period of rest before the next eruption. Geologists meticulously monitor the ground above, searching for clues. They look for subtle swelling, minute changes in the landscape. This is a telltale sign the chamber is inflating, a warning sign of potential eruption. Miles of solid rock create immense pressure, a force that's hard to imagine. This pressure is thousands of times greater than the air pressure we experience at the surface. A truly extreme environment. It's this pressure that keeps the magma and its dissolved gases contained, preventing a premature eruption. The chamber's walls are in a constant battle, a struggle against the forces within. They are constantly resisting the immense force within, the relentless pressure of the magma. It's a delicate balance, an unstable equilibrium that cannot last forever. Nature is patient, biding its time, building up energy, but it is also relentless, and eventually that pressure will find a way to be released. Where does magma come from? It begins deep in the Earth's mantle, a layer of mostly solid but incredibly hot rock. For rock to melt into magma, conditions must change. Usually a drop in pressure or the addition of water. When tectonic plates pull apart, pressure decreases, lowering the melting point and allowing rock to become magma. Subduction zones add water to the mantle, further lowering the melting point and fueling explosive volcanoes. This magma, less dense than surrounding rock, begins a slow journey upward. It collects in magma chambers, a process unfolding over thousands or millions of years. The chamber acts as a holding tank, gathering molten material from below. As it fills, the stage is set for eruption. The volcano above may seem quiet, but its fiery heart is growing stronger. Over centuries, the internal furnace burns hotter and fuller. The eruption is only a matter of time. As magma accumulates, pressure inside the chamber builds relentlessly. Fresh magma adds volume, pushing outward on the surrounding rock. The ground above may swell, a subtle sign of mounting pressure. As magma cools, minerals crystallize, forcing dissolved gases to form bubbles. These bubbles expand, dramatically increasing pressure like shaking a bottle of soda. The chamber becomes a pressure cooker, pushing against miles of solid rock. The relentless force seeks out weaknesses, fractures or faults in the rock. Tiny earthquakes may shudder through the mountain as it strains under the stress. This build-up is the engine of eruption. Without it, magma would simply cool and harden below. The combination of new magma and gas bubbles creates an unstoppable force. The volcano is now primed, a loaded weapon with pressure as its trigger. All it needs is a way out. The stage is set for a dramatic release. The rock above the magma chamber is strong but not perfect. Natural weaknesses and fractures formed over millions of years become targets for the relentless pressure below. The magma acts like a hydraulic jack, forcing open cracks and creating new pathways upward. This process, called hydraulic fracturing, is the first step toward eruption. Magma wedges into these cracks, widening and extending them, forming a network known as a dike swarm. The mountain groans and cracks, often accompanied by small earthquakes. Magma zigzags upward, following the path of least resistance. Eventually, a rising column of magma finds a clear path, either reconnecting with an old conduit or forging a new one. Once this connection is made, the ascent accelerates. The cork is loosened, the contents are about to be unleashed. The volcano is ready to erupt. With a pathway open, magma begins its final rapid ascent. As it rises, pressure drops, and dissolved gases burst out, forming bubbles, a process called exsolution. The magma becomes a frothy, buoyant mixture, accelerating upwards at incredible speed. It scours the conduit walls, ripping chunks of rock along the way. If the magma is thick, gas bubbles struggle to escape, building even more pressure. This sets the stage for an explosive eruption. In its final moments, magma transforms into a turbulent mix of liquid, crystals, and expanding gas. It hurtles toward the last barrier, the plug of hardened lava at the summit. The ground shakes, steam vents from cracks, and a deep rumble signals the monster's imminent arrival. The eruption is moments away. The immense pressure from below has been building for years, decades even. The rock is stressed to its breaking point. The final barrier, weakened and fractured, finally gives way. With a deafening roar that shatters the silence and reverberates through the surrounding landscape, the volcano erupts. The force of the explosion is unimaginable, blasting the summit plug, the cap of hardened lava, into countless fragments, a towering column of ash, a dark and ominous cloud, gas and rock. A chaotic mixture of superheated material shoots miles into the sky, reaching into the stratosphere, blotting out the sun, casting a dark shadow over the land below. Lightning flashes within the ash cloud, a spectacular and dangerous phenomenon, a maelstrom of superheated material, a swirling vortex of ash, gas and rock. If the magma is runny with a low viscosity, the eruption is less explosive, a gentler release of energy. Instead of a violent explosion, lava pours out, flowing down the flanks of the volcano. Deep within the earth, it's called magma. But once exposed to air, it becomes lava, flowing down the mountain, an unstoppable river of molten rock and consuming everything in its path. The eruption is a multisensory event, a full assault on the senses, a thundering roar that shakes your very core, trembling ground beneath your feet and the acrid smell of sulfur filling the air. Visually, it's a spectacle of unparalleled power, glowing lava, a fiery river snaking its way down the mountainside, dark ash, a dense cloud obscuring the sky, and white steam billowing from the vent, a direct view into the planet's fiery interior, a glimpse into the molten heart of the Earth. The eruption can last hours, days, or weeks, a sustained release of energy, releasing centuries of pent-up pressure, a geological catharsis. Ash falls like dark snow, a gritty blanket descending from the sky, blanketing the land, transforming the landscape into a monochrome world. Volcanic bombs, chunks of molten rock, arc through the sky, propelled by the force of the eruption, crashing back to Earth, impacting the ground with tremendous force. This is the climax, the peak of the eruption's intensity, a raw display of the planet's untamable power, a reminder of the forces that shape our world. When the eruption subsides, the world is transformed. The mountain may have changed shape, its summit crater wider or deeper. Slopes once green are now covered in ash and hardened lava, a stark, lunar landscape. Rivers of lava have cooled into solid rock, forming strange new formations. The air clears and the land, though barren, is not dead. Volcanic ash is rich in minerals. Over time, it creates some of the world's most fertile soil. Pioneer plants return, seeds finding footholds in cracks. Life slowly reclaims the land, and lava flows create new habitats and even new land. The destruction was also creation. The volcano has reshaped the region for millennia. The eruption leaves a permanent mark, a reminder of the power beneath our feet. People and animals adapt, learning to read the mountain's signs. The volcano, now quiet, is watched and studied, a testament to our living planet. Volcanoes are more than destructive, they're essential to how our planet works. They vent heat from Earth's core, regulating the planet's internal energy. Without volcanoes, pressure and heat would build catastrophically. Volcanoes are master builders, creating islands, new land, and much of the rock beneath our feet. They recycle Earth's crust, bringing new material to the surface. In Earth's early history, volcanic gases formed our first atmosphere and oceans. The air we breathe and water we drink owe their existence to ancient eruptions. When we witness a volcano erupt, we see planetary creation in action. Volcanoes remind us the ground beneath us is alive, a window into the heart of our planet. They reveal the immense power that drives Earth's constant, beautiful, and sometimes terrifying evolution.